welcome to PyCon and welcome to my talk. For today's talk, I'd be going over a fundamental checklist for publishing and maintaining open source Python packages in PyPI. So my name is Kevin Lloyd Bernal, and I'm currently working as a senior software engineer at Zyte. I'm also currently a student taking my master's class in computer science at Georgia Tech. And here are a bunch of my contacts, socials, if you want to reach out to me. So what do? In Zyte, I'm part of the developer experience team, which creates and maintains a lot of our open source libraries and frameworks, which I'm going to show you in a bit. Zyte being an open source first company, we tend to have lots of different packages that we maintain in PyPI. And for this talk, I wish to share a lot of the learnings that I had in this type of work, especially for maintaining and scaling, your open source packages. So here are some of our work. For this package, this is called Scrapy. You might be familiar with this one. So this is one of the most popular frameworks for web crawling and extraction. Right now in GitHub, it has around 4,000 to 6,000 stars, and this has been around for like a decade now. So it's pretty robust. The other package is Date Parser. An alternative to this one is called Maya, which is made by Kenneth Reitz. And this one is around 2.2k stars in GitHub. So in GitHub, we maintain different types of ecosystem. First is our Scrapy project, and then second is the Scrapy plugins, which powers up a lot of different customizable plugins for this main Scrapy project. And they have around like 26 repositories each. And in our main GitHub organization, which is Scraping Hub, this was the company's name before, and now rebranded to Zyte. We have around 200 repositories combined. For the year 2022, I mostly maintained and added a lot of features, fixed some bugs, upgraded some documentation in these two repositories. As you can see here, I'm pretty much active for like the past year in this one. And this talk has been mostly inspired by my work and by my learnings across these two repositories, which I actively maintain. And some of the examples that I'm going to show you later contains a lot of screenshots and some examples from these two repositories here. So this talk is about going through the fundamental steps or checklist for maintaining open source Python packages in PyPI. So we're going to be automating a lot of the annoying stuff, like running a lot of different tests for different Python environments with different Python dependencies, building documentation, running linters, checking mypy, and so on. My ultimate goal is to provide you with an end-to-end checklist from creating your open source package up to deploying it in PyPI. So first, what is PyPI? PyPI is just a short term for Python Package Index, which is a repository for a lot of the open source packages in Python. And you can install any package hosted within it using the recommended installer, which is pip, which you probably have used before. So for this talk, I'm going to be limiting my scope into just the PyPI and pip combo. So I won't be covering Brew for macOS and Chocolatey for Windows and Conda as well. So it's just going to be this combo right here. Now, what you see here is a typical package structure, which is pretty much common in a lot of the open source Python packages in GitHub. So we're going to be going over all of these files in this talk and try to see what each file does, as well as how does it relate with one another and how does it actually contribute, to make your Python package more maintainable. So I'm going to be breaking them down into different groups. So the first thing we're going to be checking out is the most simplest one, which is the README file. It could be either in Markdown format with a file extension of .md or restructured text, an RST. It's also important to note that there was a point in time where PyPI didn't support Markdown, only restructured text. That's why a lot of the older open source packages out there are using RST rather than Markdown. You could use either one of them, though I encourage you to use restructured text to be more familiar with it because it contains a lot more directives later on, which is pretty useful for writing technical documentations in Sphinx, which I'm going to be showing you. For Markdown, there are a lot of flavors to take note of, so you could check out this link. If you're using GitHub, you'll need to follow GitHub flavored Markdown, which is also compatible for PyPI. So whatever format that you choose, either Markdown or restructured text, your README file should at least contain the following. First, the package name, of course, as well as the quick start guide, how to install it using pip and so on, how to use it, as well as how to set it up for local development. This is mostly useful for potential contributors to your project. Next is the git-ignore file. So I'm pretty sure you've used this in your project, but you could use this tool right here, gitignore.io, to automate most of these. So you just want to key in most of the keywords regarding your environment, some of the tools that you use, so that it could properly ignore some of the files that you don't really need, like these ones. Next is declaring the metadata for actually building out your package. So before we were using setup.py, but now after this PEP 518 was introduced, the de facto standard is now pyproject. This is an example of the minimum configuration that you need in order to actually build and publish your package. After setting this up, we could test it out. So let's do a test build to see if it's properly set up. So first we want to ensure that our build command is up to date. So we want to upgrade it using pip, and then finally running the command build. You should see this message right here that your package has been successfully built, as well as you should see the dist directory and this ag-info directory after the test build. So you don't need to worry about these two directories because they are ignored via the gitignore file that we've set up earlier via gitignore.io. Now I did mention that the de facto standard is now using the pyproject.toml file instead of the setup.py file in order to declare and configure your package, but it's still handy to have the setup.py to ease development, so you could do an editable install using this command right here. Though you don't really need this one because I'll show you later how to develop and debug your package or code via Tox. Nonetheless, you could still create a shim for it via this code as shown here. So in order to do an editable install, you could use this command, pip install -e, and then the current directory for your package. Now you could easily edit your code and run it at the same time. So any changes that you make in your code would pretty much reflect this installed package. Now let's have a checkpoint of what we've done so far. So far we've created 4 files here. The first one was the README file, followed by the gitignore file, as well as the pyproject, and then the optional setup.py. Right now you've actually achieved the bare minimum required to publish in PyPI. But let's check out the other files as well. The dependencies that your package needs will be declared in this file right here. So the remaining thing that you need to declare are the dependencies for development. So we only need 2 basic ones for development, which is Tox and precommit. And 2 of these dependencies would have their own subdependencies, as we will see later. So we've declared 2 dependencies inside this file right here, which is the Tox and precommit, and make sure to install it via pip install afterwards. Now let's check out what is Tox. So Tox is a tool for testing your package against different Python versions with perhaps even different dependency versions. To give you an example, suppose our code has this walrus operator right here, which is only available starting Python 3.8, but we need to support Python 3.7 as well. So how could we ensure that our code could work in 3.7? Another example is using typing.literal, which is only available in Python 3.8. But if you want to support Python 3.7, we need to import literal into this external package named typing extensions. Tox has some other alternative tools out there like invoke and nox, but for this talk, we're just going to be focusing on Tox. Now, suppose we have the following code, which uses the walrus operator. So our code is pretty simple. We have this function named word finder. It accepts a sentence and a token and could output a none value or a string value. Now, we could write a pretty basic test case for it, like checking out if the actual token is found in the given sentence, as well as if the given token isn't found anywhere at all. Now, let's suppose we want to officially support Python 3.7 until Python 3.11. So we need to prove that they actually work in all of these versions. So first, we need to create a tox.ini config file like this one. And we want to declare Python 3.7 until 3.11 here. We also want to create a test environment with the pytest as dependencies, and then actually running pytest in our test directory. If you notice, we haven't actually declared pytest in our requirements-dev.txt file. We only declared it in this tox.ini file. To run the test against all environments, we could just use the tox command, or what I like to do is use this -p flag for a faster parallel run. Otherwise, Tox would just run the environment sequentially, which takes much longer. As you can see here, Python 3.7 has actually failed because it doesn't support the whilst operator here. As you can see, after setting up Tox, it's pretty convenient to actually test out your code against different Python versions. Now, this is the hard part about open source maintainership, where you actually decide which Python version to support. But it actually really depends on your package, as well as the effort to support each one, especially older Python versions, which contains a lot of deprecations. So I would encourage you to check out this link right here, which checks out the status for each Python version. Typically, the end of life for each version is 5 years after its release. Right now, in February 2023, there are 5 different versions that are active from 3.7 until 3.11. Now, if we really want to support Python 3.7 in our package, we need to do a compromise wherein we might not want to use some newer features like the walrus operator because it's just not available in it. And this is one of the challenges of open source maintainership because we're not actually able to use all of the new features that the latest Python version provides. Now, continuing on, you could also use Tox to directly debug your code against a specific Python version. For example, we could add breakpoints in the code and run a specific Python version, for example, Python 3.8, and we could actually debug our code from there. Earlier, I've also suggested using the method of editable install via pip install -e, but my preference is using Tox because it enables you to use different Python versions. After running a Tox command, it creates a .tox directory, which contains some of the files needed for each Python environment. So if we run Tox against all of the Python versions that we've declared earlier, we're going to be seeing these directories from 3.7 to 3.11. If you want to start fresh, you could just delete any directory pertaining to a specific environment here. In addition to testing our code against different Python versions, let's also try to test out mypy in it. So we could declare the environment mypy here and then configure it to use mypy 0.991, which is the latest version right now in this recording time. Next, we just declare the command to run mypy against the package as well as the tests. MyPy is useful because in addition to tests, it could detect typing errors as well. So if we have this somewhere wherein we pass none for the sentence and none for the token, now running MyPy using Tox would actually reveal that our function named wordFinder isn't actually able to accept a value with none because our signature for it just accepts string for both sentence and token. You might argue that our unit test could pick this up, but you don't need to run any test at all because your code editor, like your IDE, would actually pick this error up, especially when your code has a lot of typing annotations like this. You could configure mypy further by updating our existing pyproject.toml config or even its new mypy.ini config file. But my preference is using the existing pyproject.toml file because we keep everything here in one file. Now let's configure codecov in Tox. Codecov allows us to check out the code coverage using our unit tests. We just need to add 2 lines of code in our existing tox.ini configuration file, which is adding the dependency for pytest.cov, as well as using the pytest.cov plugin in our pytest command here. Now, running any unit test in any Python version, for example, tox-e python 3.8, it would create a directory named html-cov, which contains the coverage reports. As you can see here in the screenshot, this module does not have 100% coverage. So we could click on this module to see what are the lines that are not covered in any tests. So you can see that this line isn't covered by any test, where we're not checking any value error that is raised if the token length is above 999. Now, you need to be careful here because these metrics for coverage doesn't necessarily reflect a properly tested code base. It just checks out any lines of code that doesn't have any unit tests at all. So if a contributor sends a PR that decreases the code coverage, it actually functions as an alert wherein you need to write more tests for that code, or maybe some tests were removed for that code. You could also configure codecov further by using this .codecov.yaml configuration file. And here's an example. You could also configure codecov in your GitHub repo, where you could add a webhook to automate coverage checks in your PRs. So if a contributor sends out a PR, you could actually see if it actually changes any coverage at all. In this example, you would see that this PR is actually decreasing the coverage by 0.40%. Moreover, for any commits that is pushed into the PR, codecov also updates its coverage by updating the comment here. You could inspect the code coverage further by clicking into this link, which redirects you into the codecov website. Here, you're able to see the code coverage differences between the current head as well as the PR coverage here. Now, this informs you if you need more unit tests for this type of module, or other types of module are all good. Even though most of your unit tests are passing, codecov would still fail if it doesn't hit a good target. In this example, this PR actually has 50% code coverage instead of the target 88.87%. Now, as an open source maintainer, this actually informs you if there are more work needed to be done for this particular PR before it's ready to be merged. To summarize what we've done in this section, we've configured Tox to run our unit test against different Python versions from Python 3.7 to 3.11. We've also configured mypy to check out our type annotations. And then lastly, we've configured codecov to check out our unit test coverage. So far, we've only touched 2 files for this section, which is the tox.ini config file, as well as the .codecov.yaml file. Next, let's cover linters. When your project picks up in popularity, other developers will start to contribute. So you need to ensure that the code style are the same across the board. You could do that by automating some linters via pre-commit hooks, which means that every git commit, the linters would run. We could also hook it up in Tox. The first linter that we'll check out would be black. So black formats your code automatically to ensure uniform formatting across the code. Note that there are some styling guidelines from PEP 8 that black doesn't conform to. So an alternative tool would be blue, which is a response to some of black's aggressive preferences. For example, blue prefers single quoted strings as opposed to black's double quotes. Let's see this in action. You could configure black as a pre-commit hook by creating a .precommit config YAML file and then adding black as a hook into it, and then installing it via pre-commit install. Now, if we have the following code here, which has this type of formatting, and if we add it into Git and then committing it afterwards, the pre-commit hook for black would be triggered. Notice that the pre-commit run would fail if black has formatted any files. This is useful later on, where we could also hook it up in Tox, where it would fail if some contributors send out a PR with badly formatted code. This is a side-by-side comparison of what happens before and after black formats your code. The next linter is isort. This is similar to black, but it only handles how the import statements are arranged. As usual, we could just edit out our pre-commit config YAML file and adding isort as a hook into it. Suppose we have the following code with this import statements here. Isort would actually format this code into this one. Notice that we could also run our pre-commit hooks via this command right here, instead of only running it for every git commit command that we do. We also need to ensure that both black and isort play well together. You can configure them using the existing pyproject.toml file, where black has its own configuration section, as well as isort has its own section. The important configuration here is to set isort's profile to match black, so their code formatting doesn't clash against one another. The last linter that we'll check out would be flake8. This is essential for finding and fixing poor code. We could set it up via the usual pre-commit config YAML file, but notice that flake8 could also accept additional dependencies here, like bugbear, comprehensions debugger, docstrings, and so on. Feel free to add or remove any subdependencies for flake8 that you want, depending on the nature of your project. To see flake8 in action, let's suppose we have this code. After running our pre-commit hook for flake8, it would actually fail with these messages. First, it complains that a docstring is missing in our public module, which is supposed to be declared here, as well as a missing docstring in our public function, which is supposed to be declared here. It also complains that some of the imports that we did aren't used at all, like warnings, any, and union. As you can see, flake8 ensures that our code is in good health. However, flake8 also might be too aggressive in its errors, but you could pretty much configure it via its .flake8 file. It may also clash with black in some cases in terms of formatting, so you may want to add the following configuration to ignore such errors. First would be to ignore the errors regarding max line length, because we just want black to take care of how it wants to format the lines, as well as having the line breaks before the binary operator, because similar to the one above, we just want black to take care of everything. Now, we could integrate all of these linters, which are black, isort, and flake8, into Tox. This means that we don't need to do a git commit to trigger them. We could just simply run tox-e linters, and all of them would run. To configure this, you just need to declare the linters environment here, which installs the requirements-dev dependencies containing pre-commit, as well as running the pre-commit command here. Notice that I've also included the show diff on failure flag here. This is useful later on when it runs on GitHub, so you actually know why your linters have failed. Lastly, if you've introduced these linters, or maybe add new linters later on, late in your project, it's important to track the commits that were made solely due to formatting changes. This makes it easier to ignore them when debugging your project's Git history. You could do this by creating this file right here, which simply contains the commit hashes pertaining to formatting changes. Now, to summarize what we've done so far, we've created our pre-commit hooks with black, isort, and flake8 by declaring them into this configuration file here. Black and isort could also be further configured using the pyproject.toml file. And flake8 has its own configuration file here. Lastly, it's also important to track of the commit hashes that we've done solely due to formatting. So whenever someone tries to check out the Git history using a tool like git-blame, they're able to ignore the commits. Next, we're going to be configuring the docs. In Python, the de facto standard for creating technical docs for the packages would be Sphinx. It's a documentation generator which converts restructured text or markdown files into HTML, PDF, and LaTeX. It also offers a lot of different plugins to customize your docs like themes. For smaller projects, you might be able to get by with just writing the docs inside your README file. For larger projects, it's typically hosted in ReadTheDocs, which is free for all open source projects. The link would look like this, and it simply uses the docs generated by Sphinx. Now, to create your docs using Sphinx, you want to install Sphinx first, and then creating a doc directory like this, and then running Sphinx-quick start. It would present you with this interactive prompt where you would just answer several questions. After that, it would initialize your doc directory with this type of structure here. And we could configure our Sphinx build in Tox by declaring a new environment named Tox and installing Sphinx and running the Sphinx-build command. Now you could build your docs via Tox using this command here. After it's built, you could check out the local docs build using this path, which would look something like this one. I'm not going to go into how to add meaningful contents into your documentation because that entails another PyCon talk. In any case, Sphinx has a full guide for it here. To show you what a full-fledged technical documentation in Sphinx looks like, let's check out a famous request library. This uses the same theme, which is the default theme. In the homepage, it shows you how to install the request library, as well as providing some useful links on the sidebar for quick start, advanced usage, API ref, release history, and so on. The next thing that we need to document is our license. So this is as easy as choosing it via choosealicense.com to compare each one. Some of the example licenses include BSD 3 class, MIT, Apache License 2.0, and so on. Adding a license to your open source project is encouraged because otherwise it would be hard for future code contributors and users to decide how to use, modify, and distribute your code. After choosing your license, simply copy the license contents into the new license file inside your project, as well as update the pyproject.toml file as well here. You could check out the valid values for the classifiers in this link here, which is added into this classifier config. This is what the license file looks like after you copied it. Be sure to update the year as well as your full name here. The next one would be badges. Badges allows a quick status lookup for your entire project. They also function as quick links for doc builds, codecov, tox runs, and so on. For example, you could add a badge indicating the latest version in PyPI. You could also add a badge for the Python versions that you're supporting, as well as if your builds are passing, as well as your docs. You could also add a badge for your code coverage here. It's also important to note that you're not overdoing your badges. You only need to show the important stuff. Here's an example of how the badges are configured inside a restructured text README file. They are just a bunch of image links. For example, in codecov, it's checking out the coverage for our master branch, as well as ReadTheDocs is pointing to the stable version of our documentation. You could easily copy these values from each of the respective platforms here. Here's another example of the badges taken from this DVC package from Iterative, where they also show the downloads per month for their package, including the other package versions in other distributions like Debian, Brew, and Chocolatey. Now, to summarize what we've done so far in this section, we've configured Sphinx using our tox.ini config file. We've also initialized our docs directory here. We've also chosen a license and updated our pyproject.toml file to indicate it. And we've added our badges in our README file. A quick recap on everything that we've done so far. We've set up everything in Tox using this configuration file, which we could run all our test environments using tox-p to run everything in parallel. It should run all tests from Python 3.7 to 3.11, our mypy typing checks, our linters, which include black, isort, and flake 8, as well as our docs configured with Sphinx. Running all Tox test environments would indicate which ones are passing and which ones are failing. Your goal as a maintainer is to actually pass all of these tests before merging anything into master or main. Since we have everything in place where Tox can run them all, it's time to prepare for the release. First, let's create this changelog.rst file, which contains the changes per version. You could also make this a markdown file instead of a structured text. In either case, your changelog should contain the version number, as well as the release date, as well as the release notes here. For future versions, you should also indicate any backward incompatible changes, as well as any deprecations that you've made to your code. Next is to create a manifest.in file, which controls any extra files that could be added or removed from the package, because by default, building the package only contains the essential files. For now, let's keep the manifest file simple, which includes the README file, license, and changelog. Next, let's automate the ReadTheDocs documentation. First, we want to create an account at readthedocs.org, authenticate with GitHub, and click Import a Project. Clicking Import a Project should show you all of the projects that you have with GitHub. You could browse through the list here and choosing the right one, as well as configuring the options for your documentation here. After that, your ReadTheDocs should be ready to go. Your new docs should be up using this link pattern right here. You should also notice that during this process, ReadTheDocs would have automatically created a webhook for you in your GitHub repo. So if you browse into your GitHub settings and into webhooks, you would actually see this webhook in ReadTheDocs. This means that any new changes in your master branch would kick off a new doc build. You don't need to do anything from here on out. ReadTheDocs would actually build out the documentation for you automatically. Next, before releasing, we also need to ensure that each head of our branches, especially master or main, are healthy. This means none of our Tox build environments are failing. We could do this by using GitHub Actions and creating this file right here. It's also important to note that there are other free alternatives aside from GitHub Actions for open source projects, which are CircleCI and Bitbucket pipelines. For CircleCI, you get more build minutes per month, which are 6,000 minutes per month, while GitHub Actions only has 2,000 build minutes per month, and Bitbucket pipelines has around 500 build minutes per month. Now, to configure GitHub Actions to run all of our Tox environments, we could use this template right here. For the first part, it just runs out our unit test against all Python versions from 3.7 to 3.11, and then uploading the code coverage results in codecov API. The other part is running our linters, mypy, and building the docs. All of this should run for every push made into the repository. After setting it up, this is how PR should look like, where all of the Tox environments should show you pass or fail, including the code coverage here. You could also check out the logs using the Actions tab in GitHub and inspecting each of the Tox environment logs here. Aside from automatically running our tests, building our docs, running our linters and mypy, we also need to automate how our package is built and sent out to PyPI. We could do this by creating a hook via GitHub Actions as well that detects if a git tag is pushed, which signifies that a new version is to be released. From there, it kicks off the entire process. To do this, you need to set up an account at PyPI and get your API token, copy this API token to your GitHub secrets, as well as creating a GitHub workflow publish.yaml file. After creating your account in pypi.org, you could create a token for your entire account, which should work for all of your projects, or create a project-specific token. After creating the token, you just need to copy it in your GitHub settings inside your secrets variable here. Let's name it pypi_token. This variable would be used in our configuration file here. If you notice, there's also a template for publishing PyPI packages here available in GitHub. This entire GitHub Actions workflow would only be triggered when a new tag conforming to this pattern is pushed. Before the actual release, it's also important to check out if your package is set up well. We could use the PyPI test server for this one before actually releasing to PyPI. First, register at test.pypi.org. Note that it uses different credentials compared to pypi.org. Next, run python-m build to build out your package. Then install the twine package, and then use twine to upload your build package into the test PyPI repository here. After a minute or two, you should check out your repo available in test.pypi.org using this link here. You could also install it via pip install and ensuring that test.pypi.org is used as the index. Everything should work here before you actually publish to PyPI. To summarize what we've done in this section, we have created our changelog, which contains our release notes. You should update this for every release. We've also created our manifest.in file, which contains other files that we want to include in our package. And we've created GitHub Action workflows to configure automated tests, as well as automated publishing to PyPI. Finally, for the actual release, we just need to update the version number in pyproject.toml file to ensure that it's correct. And assuming that the version is 0.0.1, we just need to run the following commands. First, create a git tag for it, and then push this sed tag to the repository. This would kick off the GitHub actions that we set out earlier. After a minute or two, your package should be built and should be available in PyPI. Otherwise, check out the GitHub Actions log to see what went wrong. For a successful release, you should see that the GitHub Actions are all in green. You could confirm this further by checking out the logs for building and publishing. And you should see the confirmation that it's actually been released in PyPI here. And that's it. Your open source repo is now fully automated from start to finish. Thank you.
Maybe in the meantime, while we're waiting for the further clarification on our question, I think I'd like to ask a question of my own. So, as somebody who's still a computer science student taking my undergraduate, the idea of developing open source packages is something that I've barely had any exposure or experience in. So, I guess the question that I'd like to ask is, how do you come up with the packages that you develop? How do you identify that, oh, there's a need for this, and I should probably try to develop a package for it?
I think my tip for that one is try to solve your own problems. My first ever Python open source package was a client for Uber, for an Uber API. So, before Uber was here in Manila, where it was sold to Grab for 20% and so on. I use usually Uber for commute, and I was trying to make my commute time more efficient, or make the prices more efficient. So I tried to graph what are the Uber prices for Monday to Friday for 24 hours of the day. So I actually know what's the optimal time to actually book an Uber ride. And I actually published that one as my first ever GitHub project in Python. And it took me a while to actually go through the steps of start to finish, because there's a lot of stuff that you need to configure in PyPI. So I would say just try to look and try to solve for your problems out there, and just don't hesitate to build a package around it and show it to the world and upload it to PyPI.
All right. So thank you so much. That's so interesting to have that as your project, like optimizing certain parts of your life by coding. I think a lot of our viewers here today can be inspired to do similar things for themselves, along with the fundamental checklist that you presented us in developing our own packages. Now, I think we can go back to the question asked by one of our viewers earlier. This is the follow-up for what they meant. I'll be sending it here in our chat. So they said, like for README.md, it doesn't work with 3.11 because binaries don't exist. So I think this is with regards to the versioning of Python.
Wait. Yep, I see. Yeah, so there are some actual projects out there that don't use, that actually doesn't specify the Python version required for specific dependency. For example, one of the headaches that we usually have for maintaining Python 3.7 is that there are some type hints out there that doesn't exist in the typing package built into Python. So what we usually do is use typing extensions. And we just want this to be installed if the user is using Python 3.7. So yeah, it's pretty much really depends on the maintainer as well. But I think it's just, they probably just forgot to specify the Python version for that one.
All right. We hope that answered your question. Marvin, if you have any further clarifications, feel free to sound off once again in the chat. So now moving on to our second question from Julia Camille Las. Does PyPI check for redundancies in packages, or can there be multiple packages for the same problem?
When you say redundancies, it does check for redundancies in name, like PyPI doesn't allow uploading the same or like existing package in the same name. But in terms of redundant packages for the same problem, I would say it's not checking for if it's actually solving the same problem. For example, in one of our repos, we have date parser, but for date parser, which actually accepts just an arbitrary string and tries to extract and convert whatever date is present in the string. There's a lot of other alternatives out there, like what Kenneth writes has created called Maya. So yeah, PyPI contains a lot of different packages that solve the same problem. But that's the main good thing about open source, because there's a lot of different solutions to your actual problem, and you just need to pick the specific package that actually works for you.
All right. So Julia, we hope that answered your question. We're moving on to the next one from Ben Iglesia. I'm going off tangent here, but how does your team manage a ton of PRs in an open source package? At the moment, Scrapy repo has 200 plus PRs.
That's a good question. In Zyte, we actually have a dedicated open source team, which I'm partially on. I'm not actually a main maintainer for Scrapy right now. I'm in charge in some of our other repos. I don't want to touch Scrapy because it's just really huge. It's really mature, and there's a lot of breaking changes if you move things here and there. But yeah, we do have dedicated open source maintainers for them, and for each repo, there's like assigned engineer or a developer for it. It's also there's a lot of contributors as well, so that makes it easy for us to add new features and so on. So the main thing that maintainers tend to do is just review their PRs, check their PRs, as well as just building out core features, as well as dictating the roadmap for the project.
All right. So now moving on to our next question from Nino. I'm not sure how this is supposed to be pronounced, but pip or poetry? Hehe.
Yeah, I did use poetry before, but I stumbled in some problems, especially with like there was a bug somewhere in poetry like a few years ago where it could not resolve some dependencies, like its dependency resolution engine. It doesn't work for some reason. In that case, a lot of the teams in our company switched to old school pip, but we still use the lock file. So we use pip tools, to lock in the dependency versions. So we still use the lock files out there. And in terms of versioning, we just use Tox because it's able to handle multiple versions out there.
All right. So I think that's our last question for now. Maybe we can have our last call for questions until 2:50 if anyone else wants to ask. Oh, we have a new question. So from Ivan Dominic Baguio, do you also use pip-tools?
Yes. So in some of our repos, I believe we use pip tools, especially internal ones, because we need to lock in some of the packages. We also have our internal PyPI hosted internally in our organization. So we do need to ensure that the versionings for those are locked in. So yeah, pip tools all the way.
All right, pip tools all the way. Now, next question from Mario Sur. Do you check for malicious codes or packages?
Not in all repos, because some of our packages or the open source package that we maintain are not really used in like sensitive stuff. For example, in date parser, it's just trying to parse dates. It doesn't, actually try to connect to a database, and now you have to check for tainted, queries or injections out there. But we also want to ensure that we don't use as much third-party dependencies out there. So we usually, if there's an available function or utility in the Python built-in library, we just use that one or create our own. So that means we have like less dependencies in our packages, which is also a good thing, because the more dependencies that you add into your project or package, it tends to be a lot of a bit convoluted, and you would see some conflicts here and there, like this package requires, let's say AWS CLI to be this version, but this package doesn't allow that one. So there's a lot of clashings if you tend to introduce a lot of third-party dependencies.
All right. I think I'd like to follow up on that question personally. So it does get quite messy if you have a lot of dependencies, not just with open source packages, but in terms of the projects that we work on. If a dependency goes whack, then everything kind of gets messy. So for you in your current work at Zyte, how do you deal with that?
We typically just make our own dependencies out there. For example, we have this parser for URLs. And as we know, different HTTP clients have different ways of dealing with URL structures. Because we have tons of RFC. This RFC clashes with this RFC. And in that case, we just make our own open source package that is maintained internally, as well as open source as well.